Another way to represent the cardiac cycle is to use a graph. On the x-axis here we see ventricular volume of blood. This is the amount of blood that is inside the ventricle. The y-axis represents ventricular pressure. The four dots are the actions of the valves. The dot on the lower left corner is A, and that is AV valves open. B is AV valves close. C is SL valves open. And D is SL valves close. Between A and B is when the ventricles are filling up with blood, because at B, the AV valves close. The ventricular filling is complete. So from A to B represents ventricular filling. The second stage is B to C. At B, the ventricles are increasing in pressure, but all valves are closed and no blood is flowing anywhere. So the stage between B to C is called isovolumetric contraction. We know that C is the dramatic event when SL valves open. So from C to D is the ventricular ejection. At D, SL valves close, and so all valves are closed right now, but the pressure in the ventricle starts to go down because the ventricles are now relaxing. We call that isovolumetric relaxation. All of this together is one cardiac cycle. So at A, we have AV valves opening, ventricular filling begins. At B, AV valves close, ventricular filling ends, and isovolumetric contraction begins because the ventricular pressure starts to go up. At C, the pressure is so high that SL valves open, beginning the ventricular ejection. At D, SL valves close, which ends the ventricular ejection and begins the isovolumetric relaxation because the pressure starts to go down because the ventricles are relaxing. Here we have one full cardiac cycle. The volume of blood in the ventricle keeps changing. At B, at the end of ventricular filling, the ventricle has the maximum amount of blood. We call this end diastolic volume. During ventricular ejection, the volume of blood that leaves each ventricle is called stroke volume. At the end of ventricular ejection, which is D, the volume of blood that remains in the ventricle is called ESV, or end systolic volume. Let's review those blood volumes. EDV, end diastolic volume. This is the blood that is collected in the ventricles at the end of ventricular filling. So it is the maximum amount of blood that is in the ventricle during a single cardiac cycle. The next volume is stroke volume. Stroke volume is the volume of blood that leaves the ventricle during each heartbeat. It has to be the same on both sides. Each ventricle has its own stroke volume and they have to be equal. So here we have it. Stroke volume is the volume of blood leaving the ventricle during a single heartbeat. ESV, end systolic volume. This is the blood that remains. You gathered a bunch of blood, you ejected it, whatever remains is ESV. So ESV is basically EDV minus SV. So this is the volume of blood remaining in the ventricle after ventricular ejection.